Let's review the techniques to try for working around assumption violations. So remember last week we talked about these various assumptions, and when they're violated, what are the things that we can do to kind of mitigate against that issue. Okay, so the first one I would say is check for outliers and consider deleting or Windsorizing those outliers. So if the outliers are having a disproportionate effect on your results, either in your favor or not in your favor, then you should consider doing some things to avoid that issue. So Windsorizing is a helpful technique. I haven't used it yet, but I might consider using it in the future. Field has a lot of good things to say about it, and that is basically taking each outlier, and if it's a extremely high outlier, so it's way far away from the mean of the rest of everybody, then you would simply take the highest data point that isn't an outlier and replace that outlier score with that one. If it was low, you would do the same thing. You would take the lowest point in the data set that's not an outlier and give that outlier that value. And that's a nice way of being true to the data, unless, of course, you believe that this is a typo, that someone made an error in entering or collecting the data. In that case, we may want to delete it altogether. If there's any question about that, consider deleting it, especially if it's having a huge effect on the results. Use bootstrapping estimates when residuals are not normal. So non-normality, in my experience, happens quite a bit, but the bootstraps help with that. So for mediation, especially when we study that later, bootstraps are great for estimating the indirect effect, and so that's an easy way to get around normality issues. You can use the SPSS bootstrapping as well. So both SPSS and process provide bootstrapped estimates, which are helpful. Check for a curvilinear relationship. So a lot of times the assumptions of homoscedasticity and non-normality are violated simply when we're assuming linearity when we shouldn't. So check for that. That probably should be one of the first things to check, is that the relationship is linear. For heteroscedasticity, there's a special type of bootstrapping technique. I don't think SPSS has this one. However, it's available in process. You can ask for it on a menu. It doesn't come up by default, but it's very helpful. You could also use a weighted least squares technique that Field talks about in his chapter, Beast of Bias, chapter 5. We can conduct a multi-level modeling analysis or repeated measures ANOVA for cases of time series data. So when we are measuring the same individual on the same DV, outcome variable, over time, that means that we have correlated residuals. And so we would want to use a different technique that's not OLS regression that we're learning here. And MLM and repeated measures ANOVA covers that. And finally, for nested data, when we have individuals nested within teams who are nested within orgs, that's a 3-level model actually, so that would be complicated, but it's doable. When we have nested data in this way, we can expect that the residuals will be correlated. So we don't want to use an OLS regression in this case, and a repeated measures ANOVA is okay as well, but it's probably, I'm sorry, not repeated measures ANOVA. There's another technique that some folks use. I don't recall what it is, but it's not appropriate. MLM is the best for nested data. So we'll learn more about that next quarter. Don't worry about that now. Just know that these are some of the techniques that can be used to get around some of the assumption violations that we see that may come up in our data. So use this as a reference as well, but know some of these techniques and what you could try.